Hello everyone and welcome back. In this video, I'm going to go over some horizontal background scrolling. So with that said, let's do this. Alright, so let's get started. So we're still using the Nerdy Nice Mirror website. We are under the advanced tutorials, the third one. Horizontal background scrolling, so we're going to go over the scrolling for the NES. But before I even go to the main material that we have over here, let me show some other great resources you have. First of all, we have the NES dev over here. PPU scrolling, which has pretty much all the information that you're pretty much going to need for the, or ever will need for the scrolling for the NES. And as well as always, they always have this, some great output, some great, here, well, here's the output, some great graphical diagram. Here's this movie is showing you not only how it works, you have the tuning table, and here's the output generated for the screen. So only looking at this diagram moving over here, this GIF, you already got an idea how it works. So it's always a great resource to have, regardless of whatever material or whatever section you're working to the NES. Come here in the NES dev, which has a bunch of other great resources to have. But I believe a great scrolling tutorial already was made. It was by Don Miller. So it says here 11 years ago, but actually it was February 2010. So from the time of this recording, pretty much more than 12 years ago. Of course, the NES came out a long time ago, so I think this information has been known for way longer than that. But let's go back here to the main subject. Okay, so let's review first our name table over here. And you already have here a great ASCII art for the name table. I'm going to go over the emulator, but basically you already see that we have 4 of them. And there are 4 different addresses under 2000, 2400, 2800, and choose C00 hex. All of this. So one name table has 32 by 30 background tiles, which covers one visible screen, so one entire screen. But including the attribute tables, we need 1 kilobytes of PPU RAM. But even though we have all these 4 screens over here, and each one of these, I'm highlighting, requires 1 kilobyte of PPU RAM, and NES only has 2 kilobytes of PPU RAM, meaning that all this other data is just going to be mirrored or copied over here under this other. Well, let me show you here the emulator running. Here I have Mega Man, and here I have the PPU viewer. So if I put here side by side, if I put my arrow over here, you already see this is under the location 2000, so match this one. And this is on 2800s, the 2400s, and the choose C00 range for our tables. So as you see, this already being copied or mirrored to the bottom on this vertically version. And to do that under our games, you have to set our INS mirror for 1. So vertical mirroring for horizontal scrolling. So we set this to 1. So setting it vertically means this 0 over here and 2 over here is start vertically, and the 1 and 3 over here is start vertically. And we set this to 1. However, if you do need to change this, well, come here on the INS header, under this documents that we have over here, the NESM over here, and you see over here 0 for horizontal scrolling. Oh, I'm sorry, horizontal mirroring. 1 to vertical mirroring. You have other options over here, like battery backup, 4 screen, VRAM, and a trainer over here. So you can look up all this extra information needed. So let's go back to the main part over here. So this is what you want over here. This is what you want for horizontal scrolling. When you're looking at name table 0, go up to the right, name table 1 to the view. So this and this, I pretty much want this 2 over here, which always makes sense. You don't want, it's easier for us to, let's go over here, the NES WIC. So 2024 C100, you'll see how it works here to generate an output. It's just easier visually for us. So even if I go back to, go back to this version over here, you'll see if I just scroll this part to this part is easier instead of doing this and this. So it makes a lot more sense. So that's the review of our Nametable. So let's go over the other part, our scroll registers over here. So before we go over the scroll registers for this tutorial, which just quick clarification, as soon as you start reading this tutorial, I think the author also used scroll registers not only for the PPU port at location 2005, but also as the variable for the sample code. So if you watching this video, you can come down over here, download the sample codes over here, scrolling, which there's 5 of them. So let me go up over here and let me go open this code. So it's scrolling 1, 2, 3, 4, and 5. Well, I'll take you out of the way. 4 and 5. And sometimes they also refer to the register scroll as a variable. Well, at least in this case, it's kind of like a variable. This is pretty much reserved space. Starts at location 0. So at location 0, you're going to store the scroll values over here. So it's like, you can think of it as a variable. But I'm going to move back to the code over here. So you go over the scroll registers. But before we start going over all of that, let's first fill our name tables, which is pretty much a name table 0 and 1. So 2000, 2004 hex, which you can see right here on this diagram. And it's pretty much the same code that we've seen always before. So we set the latch. We put the location that you want to write to PPU. Oh, excuse me. And then you're going to put this 7F, which is the palette that we want, into the PPU. So at location 2000, which is the beginning of name table 0, all the way to the name table 1. So that's why it has 356 times 8. So 2 kilobytes of data to fill both name tables of 0 and 1. Just putting this palette over here. And then you have this, of course, this X and Y, because it is a 2D array or 2D matrix or a string. So we have both X and Y coordinates. And here for the name table. And exactly the same thing on field 64 bytes. So we have this, well, this allocation 23C hex. That's the beginning of attribute tables for name table 0. And 27C 0 hex. That's the name table 1 attributes. Same code, storing. The only difference that we're storing here, it's going to be palette group 0. And this is going to be palette group 3. So differentiate between the two name tables. And let me just run this code so you have an idea what's going to happen on this, at least on this sample. So run, compile code, run emulator. So that's why you have this blue background going to the red, and then we flip back together. So go back to start at 0. And if you go back to the tutorial, this first section is scrolling 1.asm. So that's the code that I just ran. So I have this field. Now let's go over the scroll registers, or the PPU register allocation 2005 hex. So like most of the PPU registers over here, we need to write twice with. So first, we give the horizontal count. So here on the sample over here, the left to right. And the second, we give our horizontal count, which is vertical scrolling. So up to down. So if you want to do a Super Mario like level from left to right, as you're going right to the level, you gonna write in the first register and set 0 to the second. But if you want like one of those shoot 'em up and down like games, then you're gonna set this second write as our vertical scrolling and have no writes on the first. It's pretty much straightforward. So where was it? Left to right, and it begins at the leftmost side of the screen. So now let me go back to the code over here. Run task, run emulator. So this begin all the way to 0, going all the way to the screen, then we flip back. So we begin at the PPO viewer over here. So we begin here at 0, scrolling, and go back to the left. So this is a left to right kind of scroll that we have in over here. So let me go back to the code, to the tutorial at least. And okay, so I begin at location 0, left side of the screen. As I said, the scroll registers are both 8-bit registers, making the scroll range from 8 to 255. And the whole horizontal screen is 250 pixels wide. So the horizontal scroll cover one full screen over here, so we can do the whole full screen. And this is the sample code over here. So let me go this. Now I can go over this to the code sample over here. What is over there is right over here. Oh, this has bigger text, so let me go over here. So the same code as before. So the main meat is right over here. So this is per DMA. So first you claim the PPU address as 0, 0, 0. Then all we're doing is once per frame, because we're no mask will interrupt once per frame. You're going to increase the scroll register. So let me go all the way up, our variable over here. So that's why the tutorial sometimes refer to the scroll registers as PPU location 2005 is sometimes the variable. So this is once per frame, just increase this variable, and store location 2005, just increase your horizontal scrolling. So that's all the code is doing. And to give a sample what 2005 does, for what you uncomment this, increase this by 50, just as a sample. So just 50 all the time. Let's compile code to make sure the changes are made. Run emulator. You can see how there's no scrolling, but I am doing the shift of this scrolling over here. And you can see how there's most of this blue section over here. And there's some of the red section that's coming up in 7. So let me go over here. PPU viewer. And this is my 7F over here. Which is one of these tiles right over here. That's what's happening over here. So it's blue and it's red. And if I were to take the thing out over here, that's the code that we had before. So you know, wait, what's gonna happen? Oh, I press compile twice, running it later. Let me just reload. There you go. So go back to the tutorial. And then lastly, we have our PPU cleaning section over here. So we have the location 2000. And if you're already seen the Dan Miller tutorial, which I have right over here, he does go over the location 2000. But in here's diagram section over here, he simply leaves as a 0 or a 1 section, which is true, but there's a little bit more to that. Because as you see here in location 2000, much like most of other PPU registers for the NES, or even for the Atari 2600 tutorial, each one of these bits has a different different value, so it's more than set this to 0 or 1. You sometimes, at least in this case of this code, all these bits has different sections. You see enable once per frame, sprite from table 0, background table 1. Well, this case is 0. But if you come to the, probably did I change it? Yeah, apparently I did change it. So that's background table 1. And I already have this running, so let me come over here. Let me just to demonstrate that more clearly. Massum. If you go over the location that we need, and it's like location 2000. If I put my mouse over that location, here it is, PPU control 2000. You have all the different bits, from the most significant bits, which generate or once per frame over there, and all the way to list significant bit, theme base table over here. So all of this address over here, 2000, all of these bits have a different value, as you can see from this, at least the whole text over here. And let me just go over, let me go to the tutorial, which the section over here is going to explain a little bit more 2000 here in the bottom. But since I'm already going over this section over here, 2000, if I were to, let me close this, go back over here. So this is 1 now. So let me just, I don't know what I had before, so let me compile and run the code, running it later. So here I have red to blue, and then you're gonna go back to red to blue. If I were to switch this to 0, run the code. Run code, compile. Let's run the emulator. Now it's blue to red, and then it's gonna reset back to blue. So that's the whole 2000 PPU address. So it has a lot of functionalities on it, not only just a 0 and 1. So let's go back over here. And all of this, of course, is available at scrolling.one.asm. So going over the nametable register, but if you come over here to our scrolling2.asm, which is this part of the tutorial, nametable registers, the register is pretty much referring to our variable over here under this location. So this is location 1. So like it's saying, just keep in mind, sometimes registers mean as a variable and not a PPU registers. And here I have already opened, where is my emulator? And you see the problem with this they want to solve. So it begins at blue, go all the way to red, and it goes back to blue right over here. What I want is just to keep it red and then go back to blue, so we can have this smooth transition on our scrolling. So that's this section that we want. That's pretty much what this diagram is showing over here. So we look at nametable 0, 1, we're scrolling, we go to 1, when you're done, go back to 0. But what we want to do is set this nametable to 1. So we are at 1, stay at 1, and then go to 0. So it's almost like you're flipping this side and bringing it over here. So this, bring it over here. That's pretty much what you're doing. And to do that, we're going to do what I just discussed before. Let me go back to the code over here. Let me go to the bottom of this section. And that's what it's explained right over here, this 2000 variable over here, whether it's 0 or 1, which you just went over. So right over here, so that's what this is telling us, what you do. And let's just look at the code. Let me go over the code. I think it's easier. Actually, this is a bigger font, so let me go over here. So we're over here. Can you create? Oh, there you go. So I don't like it. So let me go over here for now. All right. So we're incrementing this scrolling once over here, once per frame, and then we're gonna do a non-swap check over here. And then we're gonna load the scroll over here. So this, let's go back to the code. This string's way easier because I can just, for example, if I hold this, highlight this area, is gonna not only give me the whole section of the code, so it's a bit easier over here. So once per frame, I'm gonna increment the scroll. We have this section over here, this label, which don't seem leads anywhere. All right, so you're gonna load the scroll over here. So load the value we have. And while it's not equal 0, you're gonna build this, our nametable check done. So we're just scrolling as is. So, and you can see from the code. So spare DMA, it's fine. Run the other graphics, whatever. Clean the PPU code registers and do the same thing. So load the scroll, store this first, second right. And here we have our reloaded value over here. And then you're going to do this exclusive OR. So let me go back to this tutorial, which is right over here. Well, the code is over here too, but I like how it's bigger font over here. So we're going to load this variable that we have, which is either 0 or 1. You're going to, all this exclusive OR is doing is flipping. So if it's the value 0 in this name table, it's going to be 1. And if the value is 1 in this name table, it's going to be 0. So all exclusive OR is doing is getting a value in flipping between 1 and 2. And so we'll go back to the code over here. It's doing the same thing over here. So if it's name table, it's either 1 or 0 in this case. So this is going to be 0. Since it's going to be, since it's a 1 or 0 is just actually 0, 0, 0, 0, or 0, a bunch of zeros and 1. So just working with the least significant bit. So it's going to be 0 or 1. And then I'm going to start in the name table. So if it's not 0, do all this scrolling as I was doing before. But if it is 0, we're going to take this name table, it's going to flip either 0 or 1. So you can see how the code is working. So it is starting at 0 on the left side. So come over here, I think it's easier. Starting at 0 on the left side, so it's scrolling, 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 scrolling. Overflows back to 0. But now we're going to switch name table. It's right over here now, because we flipped the name table. So it's beginning over here, scrolling, 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 scrolling. Get over here, overflows again. So we're going to switch. It begins over here. So if I were to run the code over here, you'll see how it works. So let's see, run, compile code, sure all the changes I made, 1 minute later. And here it is. So blue, red. It's not flipping back to blue, it's still red. And here it is. Now I get this smooth transition between these two name tables that we have over here. So let me go back to the code. PPU, name table master. So the full code is available on scrolling.to ASM. So let's go over drawing new columns. So to do that, well, let's go back to the other sample that I have here. So input 2 and run over here, run it later. And already can see some of the defaults that we have over here. We have this blue over here from red and back to blue. So it's not really a default, but that's, we achieve what you want to do. This seamless transitions between these two name tables that we have over here. So you're on the PPU viewer. And by the way, I forgot to actually set this up to explain to you guys better, but with this, you can see how the Don Miller tutorial that I recommended in the beginning show you how name table 1 is over here, name table 2 is over here, and how this camera is going across it, so it looks like it's actually scrolling. So, well, better late than ever, but helpful tool over here if you have trouble. Well, this tool, this section over here, helpful tool if you're having trouble understanding, visualizing everything over here. But what you want over here, if you go back to the, go back to, come here, Firefox, here it is. And that's fine for games like Super Dodgeball, if that's where you choose to do. But if you want a game where something like Super Smash Bros., which is a wider level, which has a lot of other stuff happening, you're gonna have to, well, actually, let me just open Super Smash Bros. So if you want a game like Super Smash Bros., like I have over here, and let me open the PPU viewer. So this is on, okay. As you see, all these red tiles means that it's being updated. Sometimes it's yellow, I don't know what's the difference. But as you see over here, you'll see this off the screen that's happening. I'm getting this updated tiles off the screen. And as I go forward, that's how we're getting this illusion of this seamless transitions between these two name tables. And with that in all of those components on, we get this, our scrolling, at least our horizontal scrolling, but the concept's still the same for our vertical scrolling. So let me make you guys proud over here. Man, I thought this level was shorter. Let's see. Wow. Okay, let me close this. You guys never saw that. Okay, so what we want to do is what you saw. So you update this column over here on this diagram of the screen every time we scroll the screen around. So, but to do that, we need to know 3 components: when to draw, where to draw, and how to draw. So when we draw, and that's pretty easy because here's only 3 lines of code. So we will draw a new column anytime the column it says rasters, but it means a variable. Our scroll variable becomes multiples of 8. So meaning that it is aligned with the tiles because the tiles are 8 pixels wide. So every time it is 8, then there's a new tile to be drawn. And to do that, it's pretty easy. We load the scroll, which is being incremented once per frame. And then we do a mask, so we throw away all these values over here, as it explains over here. We only keep the values between 0 and 7. So 0 to 7 are 8 values. So every time it's equals to 0, you're going to draw a new column. So that's pretty easy. That's why it's 3 lines. Now let's go over the second line, which is where do we draw? That's our second component. And we need to know where to draw between name table 0 and name table 1. And where within this name table. So if name table 0 has 32 pixels, and 32 tiles, and name table 1 has 32 tiles as well. So not only we should know which name table we're drawing, we want to know where we actually drawing within this name table, within this 32 tiles of each name table. And to do that, we're going to have 2 new variables, column low and column high, which is, we go over here, scrolling tree, column low, column high. So column low is going to tell us where within these 32 tiles wide we are over here. In this sample, is going to be on name table 1 in this green section of the screen. So let's say if those are all equal, 1, 2, 3, 4, 5, so the 6th one. As a not as representation, it's a little bit off, but you get an idea. So I'm going to load the scroll, and I'm going to do 3 logic shift rights over here, shift right 3 times, which is the same as dividing by 8, because every time you do a shift right, you divide it by 2, do it 3 times, divided by 8, then we store that into a local column, because now we got where within this name table 1 in this sample we have it, but it can be anywhere over here. So now we need to know where and which name table we're doing. Is name table 0 or name table 1. So that's going to be stored in column high. And to do that, you just get the name table that it's currently on. And then we're going to do a exclusive OR. So it's going to reverse the value. So you get to stay off the screen 1. And do a arithmetic shift left. And you're going to do that twice. So here's A and A. Meaning that if it's 0, so multiply by 2, and multiply by 2 is always going to be 0. Regardless, multiply by 0, 0 is always 0. And if you multiply 1 by 2, it's going to be 2, and one more time is going to be 4. And then we got either 0 or 4. Clear the carry every time we want to do an add over here at 20. And then you're either going to get 20 or 24. It corresponds to name table 0 or 1. So it's going to be either, go back here to the sample, either 20 or 24 for the high byte, and we got the low bytes by dividing by 8. And thus we know where to draw. And lastly, we need to know how to draw. And that's going to be a useful PPU registers at a location 2000 over here. And that's going to be this one, the third bit over here. And if you set this to 1, it's going to get this plus 32 mode. We don't really care the other bits because, go back to the code, because really there's being updated here as well. So that part doesn't matter. So, but what does matter, we set this third one to 32 increment mode. And if I run Super Smash Bros over here, the third one as well. So this is what this sample is doing. But you can see here, PPU viewer. This red section here is being updated, and that's the whole string over here. If you see on Mario, you're gonna pretty much Super Mario Bros. You're gonna see that as well. PPU viewer over here, being updated. So all that updated. Here's being drawing the updating as well. Well, it's not covering the whole thing because the scoreboard is being left intact, and that's gonna be this next video. But you can see how it's updating this whole bright area over here. Let me close that, and we'll go back to the section that we want. So set that speed over here, and then you're gonna put where they want it. So column high, reset the latch. I'm gonna put 2006 where we wanna write our values. So let's do that. Then we have the location set. Then we setting our loop over here, which is gonna load the column data Y till it's done. So 30 bytes over here, and store that. And then we're gonna get. Let me go back to the sample. So run emulator, and it's gonna get the whole. Our whole. Let me open my PPU viewer. Get this whole section over here back to back over here. All these values over here. Let me close that. And if you come over here under column data, this is giving us all the, well, it's pretty much 0 to 1D. So giving all those values over here to fill on the screen. And get back over here and store the data. So it's pretty much the scrolling tree ASM. So we learn where to draw, when, where, and how to draw. So that's how we add more sections to it. So let me go back to the scrolling tree. And if you check this in comparison with Super Smash Bros. Over here, you can see how this camera section is smaller. So if I turn off tile update over here, now you can see the whole section. That is because it really is updating at real time. And games like this Super Smash Bros, you can see a little bit more ahead. It's because there's I'm assuming, I didn't look at the code, but I'm assuming there's some form of buffer, so it makes the transition a little bit more smoother. So let me go to the PPU viewer, run this over here. Okay, let me highlight tile updaters. So as you see, it's a little bit off the screen as I pause. It's not, so it's going a little bit. Then I pause a little bit. So it's a little bit of a buffer, I'm assuming. It makes this transition a little bit a little bit better and less jaggy, if you notice. But that is this third version, and now we're gonna go over drawing real background data. So in the last sample, we drew no columns, but it wasn't really real data. What I'll be doing is pretty much just do a quick incrementation between the first. Well, we saw the code, but it's not real level. So what we want to do is actually get a real level going, a real map. And I already have here scrolling 4 over here. So let's just run. I already have it compiled, so let's run emulator. And here it is. That's what we want. We want an actual level, something like this, that we create and we can put on the screen with the scrolling, of course. And to achieve that, so let's go back to over here. This sample that I have over here, which is the scrolling 4 over here, has another counter to keep track of how far along the level the player is. So it is pretty much, if you had, so come back over here, and here it is, our column number. So this is our another counter to know which column we are at right now. So if we're like 10 columns ahead, it's going to be column 10. So over here, by incrementing this counter, every time a new column is drawn, the correct next column is easily to find. Well, let's make a little sense. Then draw new column function has been updated to use the counter to load the real background data. It can also be used at the beginning of the elicitation populate the name table instead of using the loops that we had before. So let me go over the code quickly. So not only have this no counter, you also have this source low and source high, which is our source of column data. And this column data is being right over here, this Super Mesh Bros level.bin that we saw it running over there. It contains all the information. So something like this that you're seeing over here, but all the different nicely stacked. So let's go over here. Let me go highlight this area and see the new changes that was made. So here's the initialization. So I'm going to begin a name table 1, initialize this to 0, get started to the column number as well. And it's doing this again to name table 0. So it's not only just name table 1. And then when all of this is all set, you're going to do a jump to the subroutine called draw new column. Let me come down over here. Here it is, draw new column. So this is the code of where we were to draw on the last section over there. And this is the new section. So here we have the accumulator over here, which is pretty much getting the column data offset. So the data that's offset of the 32 pixels wide that we have. So you get the column number times 32. And then to do that, we do 1, 2, 3, 4, 5. That's a arithmetic left over here, which is multiply 5 times. So that's 2, 4, 8, 16, 32, 32. Then start that to the low source. So it's almost like inverse. So the low source get this side of the section, and the high source here gets low side of the section. And then I'm going to store that into our source high. So I do a mask over here, or the currently column number that we have. You don't really require this other two over here. I'm going to do this left shift right over here, 1, 2, 3. So it's pretty much like this, dividing that value by 8, and store that to your source high. And then we do our source low, the clear carry. And then you're going to do a add, and this is pretty much the NES emulator over here. Just give me the low, what is it, the low bit? Yeah, the low bit section. So let me confirm I'm saying this right. So this is the low section of column data, which is right over here. And then start actually the source low, which is the offset. So here you have where the data plus the offset. And then you do the same thing for the high, get the high value, column data, and store that to high. Then you got the draw new column. It's pretty much like before. Oh, you get the column high and column low before. And here we get you our draw columns loop. You get the source low. And with our loop over here, copy 30 bytes of our code over here to Y and store that to our screen right over there. And that's how we get one task over here. Running later, this section of the game right over here. Okay. In the next part, let's go over the updating the attributes. So lastly, you're going to go over the final piece of the scrolling puzzle. That says over here, the attribute table. Updating the process is almost identical to the background, but the update is pretty much identical to the sense that they're done off screen. Oh, excuse me. But again, the scrolling name tables registers will be calculated corrected. Attribute must be byte by byte, but here's the area that I want to go over. Each attribute tables cover a 4x4 tile area, if you remember correctly. And all of those tiles together has a 32 pixels altogether to this attribute table over here. So the attributes must be updated anytime the scroll registers is a multiple of 32. So it makes sense because there is, let me just run a sample for this week, this section. So let's run the emulator. I have the code compile. And here's the code. If I go to the PPU viewer, and I go show attribute colors only, or show attribute grids over here, you'll see all of this over here. It's a different attribute that's being updated over here. Let me close that. Let me close that. You already should know that from the previous videos. Well, here's the code that we're going to go over. 32 pixel wide. And to do that, it's pretty easy again. So if this section of the code was 8, putting a few more ones over here is going to be 32. So it's always powered by 2 over here, which is 32. And then we're going to branch every time it's equals 32 to a new attribute tables every time. All right, so there's only 8 attribute bytes that we need to change each time. However, they're not sequential. So this +1 over here, plus 32, is not really going to work like this. So we're just trying this. We're storing that sequentially downwards. Well, we can't do that with the attribute tables. You're going to have to actually do the offset mathematically, which you have right over here, and store that into our the PPU actual location. So let me go over this code, this section, then I'll go over the code. Here's the name table, same as before, exclusive for, get the other one. So this 2 arithmetic shift left twice, multiply by 2. So pretty much the code I had before, so you know. And then I got the load scroll, and we're gonna do 32 over here. That's 32. Logic shift right, so 5 shift right, so equivalent to 32. Add C0 over here, because this 20 C0 is the start of the attribute tables. So attribute tables plus scroll divided by 32, and you get the location. So let's go over the code. So here we have the draw new attributes over here. So let's highlight this area. It's pretty much that's changed. There's no new variable over here. And it's being used right over here. Initialize new attributes as well. So it's doing the same code as before. So let's go over the area. So draw new attributes right here. So that's the code that we just saw. Name table, scroll by 32. Then I'm also going to load the count number, doing the same code that we did before on the draw on the background. 32 offset. And then the same code part of the here over here, which is the column number divided by 4 times 8, which is going to be the column data offset over here. 2 divided by 4, which is this. I'm going to mask this value over here. So you're going to ignore 1, 2, 3 minus 4. Then you have this arithmetic shift left to the register, store that to the low column number, 32, store that to the high source. So now we know where we want our low source and your high source for our attribute data section. So we had our data section on the last level for the level.bin, and this is going to have another different section of data, in this case for our Smash Bros attribute.bin. So it's going to come over here. It's going to come at that file, which contains all the attributes, and do the same thing. So load the source low, do the offset, get the low low PPU address section, store that in the new low, then get our high section, add that to the high latch, the hard PPU address from the data, and store that into our new source high. Then you have all the necessary parts needed. So now you're gonna do the loop update. So reset over here. So then you're gonna do the low and high. You're gonna store that into our 2006 PPU port. We know where low Y. So copy new attribute types from over here from Y. So, excuse me. Incrementing Y to multiples of 8 attribute bytes. And then when you hit 8, we're done. Otherwise, I go to the next byte. So column low, clear, add, and repeating the process until we fill the whole attribute tables. And then we're done over here. Yep, not you. And then that's how we get. Well, let me run the task over here. Run emulator. That's how we get our Mario guy scrolling over here, almost like skating. And that's pretty much gonna cover this video. Go over here. So in the next video, you're gonna go over the sprite 0, which is one of the ways that people did the scoreboard over here, or the status bar. So if I were to quick preview for next video, I guess, run emulator. Open Mario over here, the actual Mario game. Open, browse, I should browse. Over here, let's open our PPU viewer, which I talked to you guys before. As you see, how it says Mario, the numbers of coins and whatnot. So there's timers being updated right over here. It's not being, and everything else on the bottom, this section over here is being updated. So that's going to look like in the next video. So let me close this, and that's pretty much it. If you're a guy like all this video so far, please feel free to subscribe, and I'll see you in that video. All right, thanks. Take care.